So this video is in continuation with the next topic of the DCCN of Unit 2nd Data Link Layer. So today we are going to discuss the next topic, which is block coding. So let's understand. In block coding we divide what is block coding. In block coding we divide message into blocks, each of k bits called data words, right? We add r redundant bit to each block to make the length n, where n is equals to k plus r. The resulting n bits block are called code words. So the combination of the data words plus redundant bit makes the code words. For example, we have a set of data words each of size k and a set of code words each of size n with k bits. We can create a combination of 2k data words. With n bits we can create a combination of 2n code words. Since n is greater than k, the number of possible code words is larger than the number of possible data words. So this is how we can create the code words. The block coding process is one-to-one. The same data word is always encoded as the same code word. Right, this means that we have 2n minus 2k code words that are not used. We call this code word as invalid or the illegal codes. So this is the diagram where you can understand how the block coding is performed. M bits data words we have, division of stream into the m bit groups. Then we have performed some substitution, then it has been converted into the n bit combination of n bit group into the stream. These are the code words. Next is linear block coding. In the linear block codes, the parity bits message which have a linear combination, which means that the resultant code word is the linear combination of any two words. Let us consider some blocks of data which contains k bits in each block. These bits are mapped with blocks which has n bits in each block. Here n is greater than k. The transmitter adds redundant bit which are n minus k bits. The ratio k/n is the code rate. It is denoted by r, small r, and the value of r is r less than 1. The n minus k bits added here are parity bits. The parity bits help in error detection and error correction, and also in locating the data. In the data being transmitted, the leftmost bit of the code word correspond to the message bit, and the rightmost bits of the code word correspond to the parity bits. Systematic codes. Any linear block code has to be systematic code until it is altered. Hence, an altered block code is called a systematic code. Following is the representation of the structure of code word according to the allocation. So here is the structure of the code word: k bits and n minus k bit. These are the parity bit and these are the message bit. Hamming codes is the example of the linear code blocks. The linearity property of the code word is that the sum of the two code word is also a code word. Hamming code are the type of the linear error correcting codes which can detect up to 2 bits error, or they can correct up 1 bit error without detection of uncorrected error. Cyclic codes. The cyclic property of code word is that any cyclic shift of a code word is also a code word. Cyclic codes follow this cyclic property. For a linear code C, if every code word, that is capital C, is equals to C1, C2 and Cn, C1, C2, Cn from C has a cyclic right shift of component, it becomes a code word. So whenever we perform any right shift, the new code word is generated. This shift of right is equal to n minus 1 left shift, hence it is invariant under any shift. So the linear code C, as it is invariant under any shift, can be called as cyclic code. Cyclic codes are used for error correction. They are mainly used to correct the double errors and worst error. So in this video we have discussed some topics of the unit 2. In the next video we'll continue with the next topics. Thank you so much.